Hey guys, I just got some questions about how to more or less do this worksheet. I think I mentioned something in the notes about having some sort of follow-up material on this, and it completely slipped my mind. So here's kind of going over how to, for the most part, how to complete this worksheet. So obviously, you know, for the most part, this is going to be a worksheet where you're using the Criss-Cross method, and you are going to, my goodness, sorry, my mind was kind of blanking there. And you're going to be using the Criss-Cross method in order to show me how many, specifically how many elements, how many atoms of a particular element, or how many atoms, or sorry, how many number of molecules are needing to be used in a particular formula here to make a neutral compound. So all of these, almost all of these on the side here, you know, you've pretty much already worked with, and if you didn't realize, you know, these are all your cations over here. Okay, so here are your cations, and then here are your anions over this way. So I had some questions that were posed from you guys, like, what do we do with these specifically? What do we do with these guys where there's like oxygen in them and they're attached to something else? What do we do? So these are those polyatomic ions that I mentioned in the notes. These guys are your polyatomic ions. So what do you do with these guys? Well, specifically what you do is that you keep them together. You more or less treat them as if they're a single unit. Even though they are composed of a number of different elements, you treat them as if they're like one entity. So as an example here, so sodium is going to mix here with bicarbonate, okay, and you just use the typical. You're going to be using the typical Criss-Cross method. So, for instance, let me get a piece of paper. It would just look like this. So, let me get a blank piece here. So it would just look like this. So you'd have sodium. Sodium here has just 1 plus at the top. Bicarbonate here has CO3, 2 negative up top, okay, and you're just going to do the same thing, but treat this guy as its own thing. So crisscross here. Now, what do we do with those subscripts? Well, sodium's going to get 2, and then since we treat this guy as just a single unit, we're going to use parentheses, okay. Every single time, this is going to be CO3 every single time. Okay, we're not going to be putting anything inside of it. It stays as is. So your answer for this one would be sodium, would be Na2CO3. Okay. Now for this guy, you really don't need to have parentheses just because you have the 1 crossing over. But if you had a 2, if you had a 3, it would look something like this. So maybe let's look at one where you would have 2 or 3. Let's see. Let's maybe try out. Ooh, this would be a good one to practice right here. So let's try out calcium and then bicarbonate here. Okay, so let's see. Calcium has 2 plus. Carbonate has 2 negative. So what do we do here? Well, we're going to cross them. Okay, and then what you're left with is it would be normally C2 and then CO3 with a 2 on the outside like that. But this is a good example to show you 2 things. So one, this is how we would represent, you know, keeping this guy as a single unit, representing the subscript on the outside of it because it's making 2 whole things of this. This is how we'd show it. But second thing here is because we are using, this is not a molecular formula, this is not a molecular formula, it's an empirical formula. This is all divisible by 2, so that it would just become CaCO3. Okay. And then one more example, just so you know we're not terribly confused on what to do here. Maybe let's take a look at, still with calcium, maybe calcium, and we're going to combine calcium with, let's say we're going to combine calcium here with phosphate. So phosphate has a charge of 3 negative. Circle those guys, and we're going to crisscross them. Okay, and then what you would have is that you would have 3 calcium. You'd have 3 calcium atoms. and we're going to keep phosphate all by himself, locked in that parentheses. We're going to toss the 2 outside of the parentheses just like that. Okay, and you'd have your answer for that guy. You'd have your answer for this guy. In all 3 of those examples, okay? So that's what you do with these guys. We really only touched on other than ammonia here, we touched on all the monatomics. We're still going to be getting into the polyatomics, and these guys right here, excluding chlorine here, these guys are your polyatomics. Yeah, we'll be getting more into depth into those guys a little bit later on, but that's how we write, represent, and what we do with these polyatomic ions. So if you still have any more questions, make sure you email me, send me something so I can get back to you on it. Okay, thanks guys.